Prakash Gurjan, you are an associate professor at Columbia University, where you teach biostatistics and genetics. So this is your second book. You came in fact in Passerelles for the first one, Classic Problems of Probability. So the title of your new book is Classic Topics on the History of Modern Mathematical Statistics, from Laplace to more recent times. In fact, in Mesopotamia, more than 500 years back, when they invented writing, in fact, it was not to write poetry or novels, but to keep a record of their stock. So it seems that statistics counting has a very, very long history.
Indeed, since the human being took cognizance of his or her surrounding, the keeping of records has been a very important task. So it is true that the statistics, which is the collection of data, its analysis and interpretation, there was a basic form of statistical preoccupation since man took cognizance of his surrounding. But the official start of statistics took place very late compared to the history of mathematics. Statistics, the official birth of statistics took place quite late, actually in the 18th century in Germany, okay, by somebody called a political scientist called Ball. So after Ball, there was a further development of statistics called political arithmetic in England, still in the 18th century, and this political arithmetic was concerned with keeping records of a state, of birth rates, of deaths, of various other matters of a state. It's only in the late 18th and 19th century that statistics was given a very rigorous mathematical form, which we call mathematical statistics.
So, Prakash, this is a big book. It consists of almost 800 pages. Could you present to our viewers the three parts of your new book, The History of Modern Mathematical Statistics?
Let me first say that the book is a real labor of love. It took me a long time, 4 years of non-stop writing to write it. The book is actually on how a rigorous tool of mathematics was infused into statistics to make it become a very rigorous discipline. The first major figure I touch in the book is the Frenchman Laplace, who has been described as one of the greatest intellectuals ever. Laplace was to France what Newton was to England, a very, very sophisticated mathematician who devoted a large portion of his life in the late 18th century and early 19th century in the development and refinement of statistics by putting tools of analysis into statistics. So he dealt with astronomical observations, how statistics comes into play when you have data, astronomical data, how you can analyze them using statistics. And he also considered what happens when you combine a lot of observations. And this leads to what is known as the central limit theorem, which is one of the most important theorems in statistics. The central limit theorem. He did not invent it, he did not discover it, but he worked a lot towards its refinement. So Laplace was a towering figure in statistics, and almost 200 pages of my book is devoted to the life and works of Laplace. Following Laplace, I deal in a lot of detail with the works of Francis Galton, who was a cousin to Darwin. So Francis Galton did a lot of, adopted a lot of ideas from Laplace and from Adolphe Quetelet to further develop statistics. He developed what is known as a regression. And following Galton, in the second part of the book, I talk about Carl Pearson, who also was a towering figure in statistics. But the central figure in my book is the Englishman known as Ronald Fisher. He is the one who actually invented the word statistic. So remember, statistics can be used in two ways. Statistics can mean the art and science of collecting and analyzing data, but statistic can also mean, it's a quantity of interest, like the average income of a person in Mauritius or in any other country, or the mortality rate of children. That's a statistic, the mortality rate. So Ronald Fisher is the central figure of my book, and I devote almost 300 pages to describe his work, how he developed what is known as estimation. How do we estimate, for example, the mortality rate or the cure rate of a particular drug? How do we estimate the pass rate of students? How do we come up with the pass rate? How do we conduct these surveys? So Fisher was the major figure who developed all these techniques of estimation. And there's another main issue in statistics, namely that of hypothesis testing. So Fisher developed the idea of a statistical hypothesis, how it ought to be tested. So a large portion of a book is devoted to Fisher. And then in the third part of the book, I talk about post-Fisherian developments, which took place in the 1950s, 60s. So there you encounter a lot of Frenchmen, Englishmen, and Americans who further developed the theories that were initially put forward by Fisher. So basically, that's what this book is about. The infusion of mathematics into statistics to make it become a very rigorous discipline.
So, Prakash, my last question. What are the applications of mathematical statistics today and in the future?
Mathematical statistics has applications in almost every scientific field you can imagine. When you're going to develop a new drug, a new medication, how do you do this? What are the techniques? You have to look for patients. How do you collect these patients? You have to randomize them. Once you randomize them, you have to follow them for a period of time, and then you have to analyze the data. How do you analyze the data? What statistical tests do you use? All of these concepts are borrowed from mathematical statistics. When you're looking at the development, a chronological series of sales of cars across time, you get a time series. How do you analyze this series to be able to make projections of what are going to be your future car sales? Again, to be able to analyze this time series, you need tools of mathematical statistics. In psychology, how do you study human behavior? How do you quantify how human beings respond to various impulses? In almost every field you can imagine, there is the input of mathematical statistics. How do you estimate parameters? How do you come up with meaningful statistics? And how do you test hypotheses? So the utility of mathematical statistics cannot be overemphasized.